All right, we can also find values of a function by looking at the graph. To find the function value, go to a given x-coordinate or input on the x-axis. Your answer is the y-coordinate of that input. Okay, so let's kind of look at some illustrations here. Here we've got two pictures. We've got a set of function values I want to find. So let's start off with f of -2. So f of -2 means I want to come over here to -2 on the x, and I want to go down. All right, so that would be the ordered pair -2 comma -1. So the functional value at that point is -1. If I go to f of -1 means come over here to that point, and what's the ordered pair there? So it's -1 comma 0, so that's a 0. Then I want 0, and I look at the y value opposite that, so that's 0, 1. Then I want 1, so 1 comma 2 is what it looks like to me. And last but not least for this picture is f of 2. F of 2, so I come over here to the x-axis at 2, go up, and it's 2 comma 3. So the y value opposite that x value is 3. Alright, looking at the picture next door, we're going to do the exact same set of skills. Starting with f of -3, so I want to come over here to 1, 2, 3, look at that point. And it's -3 comma 0, so that's for the functional value that's 0. F of -2, so come over here to -2, go up, and it's that ordered pair, so -2 comma 1, there's a 1 there. 0, f of 0, so come over here to 0, goes up there. There is an ordered pair of 0 comma 1, 2, 3, so 0 comma 3, so that's a 3. F of 2, so 2 comma 3, and then f of 3, so 1, 2, 3, right there. So what ordered pair is that? That'd be 3, 0. So f of 3 happens to be 0. Okay, x-intercepts are where the graph crosses the x-axis. Algebraically, we find this by setting y equal to 0 and solving for x. The y-intercept is where the graph crosses the y-axis. And algebraically, we get this one by setting x equal to 0 and solving for y. Okay, so let's look at some examples of just graphically. So the x-intercept, I come over here and look where does it cross the x-axis. And that crosses it at -1, 0. So it crosses at -1. The intercept is actually an ordered pair. The y-intercept here, where it crosses that, would be 0, 1. So that ordered pair would be the y-intercept. And the next picture crosses the x-axis in 2 locations. So it looks like -1, 0, and 1, 2, 3, 3, 0. And then the y-intercept only crosses there, and that looks like it's 0, comma 1, 2, 3, -3. All right, last picture here for this one. X-intercept crosses the x-axis twice. Looks like that's at -2, 0, and at 3, 0. And it crosses the y-axis at 0, 2. All right, reading the domain and range of a graph. So we're going to write the domain and range using interval notation. So in doing that, we want to recall or remember that the domain of a relation is the set of all input or x values that a relation includes. In order to find the domain of a graph, we look at the endpoints of the relation graph and look from left to right. The range of a relation is all the output or y values that the relation includes. And in order to find the range of the graph, we're going to look at the endpoints from the bottom to the top. So it's an up to down thing instead of a left to right thing. Okay, so in looking at this first picture, we want to first identify where's the leftmost part of it. So I can kind of see that the arrow is going down, but really as it goes down, it's going to be going more left, and as it goes up, it's also going to be going more right. So when I identify the domain, then there's really no characteristic of the graph that's preventing it from going further either direction. So in interval notation, we would say that this is everything. So every possible number I could think of would have a x value in this graph. So 1 comma something, 2 comma something, 3 comma something. There's going to be something there. Okay, range, we're looking from top to bottom. Well, the arrow means it keeps going, which means it also keeps going further down and further up. So going up here and going down here, there's nothing restricting it. So it also has -infinity to infinity. Okay, in the next example. Okay, the arrows indicate that it keeps going up in the diagonal direction, so I'm looking for any restrictions in the left or right, and there aren't any. There's no reason why it's not going to keep going more left or more right as the graph keeps going up and up. So that's going to go from -infinity to infinity. Going up, so that part will keep going, but that piece, the bottom end, is actually going to stop at that point. So when it stops, I actually want to take a good look at where it's stopping at. So my range is going to keep going up and up and up, but it's going to have a stopping. It's going to have a starting point. It's going to have a certain value that it doesn't go below. So what's that? What is that y value? Well, that's -1. So nothing below -1 shows up in the graph as far as the y's are concerned. So our range goes from -1 out to infinity. Okay, so that said, let's see. The next picture. Okay, arrows keep going diagonally, so that means they're going to keep going more left and more right. There's no restriction in either of those directions, so as far as the domain is concerned, we're looking at everything, so -infinity to infinity. However, look what's happening with the y value. So that arrow means it keeps going down. It's going to keep going down that way. Even though there is a stopping point here, it's not one that's going to prevent the y values from showing up in the points. There is a stopping point here, but there's a bigger stopping point here. So looking at the y-axis, right, that's the highest I'll ever get any y value to be, and it's going to be anything below that point. So so first off, what number is that? Let's see, so that would be, what, 1, 2, 3, 4, right there. So there's no y value above 4. All the y value is going to be below it, and it's any value, any number I can think of below 4 will actually show up in this graph. So my domain is going to go from negative infinity up till 4, and then it's going to stop at 4. Okay, so in this next example, we've sort of taken the arrows away. So I can see that there's a y value there and a y value, or sorry, x value there. So my domain then is going to be anything between those two values. So what are those values? Well, on the low end, this is 1, 2, 3. So we got negative 3 there, and we have 4 there. Okay, now looking at the negative 3 and the 4, are there any other symbols associated with those in the graph? Well, at negative 3, I can see a close point, so I'm definitely going to include it. But do you see how there's an open circle where the 4 is at? So that means it's technically not an ordered pair, it's sort of a border. It's an open circle of some kind. So if you think back to inequality notation, whenever we had a strictly less than or an open circle, we used a parentheses. Okay, what about range? Okay, well I can clearly see that the smallest y value is right there, and it goes up to that point. So I want to be able to include anything between those two values as my range. Well, what numbers are there? What numbers are those? I'm sorry, what's the high versus the low? Well, at that end it's 0, and counting up we have 1, 2, 3, 4. We have 4 up top there. So my range would be anything between 0 and 4, and I see a closed circle where the 0 is, so it's included, and the 4 is actually where that hump is, so that's actually an ordered pair, so we'd have brackets on both ends. Even though there isn't an open circle there, it's not, the open circle doesn't affect the range, it just impacts the domain at that point. Okay, looking at the next example. That dotted line is referred to an asymptote, sort of like a border, means we cannot cross it. Okay. Now I can see that that direction it keeps going more right. This is a little hard to tell, but it is sort of at a diagonal. So it will eventually curve and go as far out as I need it to go. So there's really nothing restricting this in the x direction. It's going to be any value on the x-axis that I want. So negative infinity to infinity. The range, however, is a little different story. So on the range, I can see there's that dotted line there, and I can see it just keeps going up forever. So there is a bottom value that it starts at, and that would be 0, but there's nothing to prevent it from keep going up. So it's going to go out from 0 to infinity. And because of that asymptote, that dotted line, it's not a physical point, it's a border of some kind. So it's like a greater than this particular value. So that would be a parentheses or a greater than symbol if we were to do it in set notation. All right, and then this last example, looking at where we have domains. Let's see, we have this, sort of have this asymptote here. So from here and there, I have x values, but I don't have them at that one particular number. So what is that number? Looks like it's negative 1. So anything before negative 1, so negative infinity out till negative 1, and anything after negative 1, and we put a little union in between that to indicate that it's the set before and the set after. Same thing with the range. I can see that there's a sort of a gap in the y values. So what number would that be? It looks like that's at negative 2. So I want anything before negative 2 and anything after negative 2. All right, the last topic we're going to address is zeros. And zeros, it refers specifically to the value of x when f of x equals 0, or when the x-coordinate of the x-intercept. In other words, a 0 is an actual number, and we look at where the x-intercept is and just write down what the x part of that ordered pair is. Okay, so as we look at examples, these next 4 examples, this is one of those times where I would say pause the video first and see if you can identify all of these characteristics before me. I'll go through and explain them all, but it'll be worth your while to make sure you got all these bits and pieces down before you get too far into this. All right, so take a look at one. There's the list of facts we want to do with it. And here we go. Okay, so our domain, let's see. So I can see it starts here at -5, and technically that arrow keeps going. So my domain is going to, oops. All right, pen here. Domain would be bracket from -5 out to infinity. Range, I can see that the lowest value is right there, and because the arrow keeps going up, it's going to keep going up that way. So my range is going to be from bracket 0 out to infinity. X-intercept is the ordered pair where it crosses the x-axis. So that would be, I'm sorry, we'll go over there. That would be 3, 0. And the y-intercept is where it crosses the y-axis, and that would be 0, 3. Zeros refer to the number when when y is 0. So where does it, look at your x-intercept, and then you want to identify just the x part of that. So the 0 of this particular picture would be 3. F of 2, so I want to go here to 2 and go up and look at that ordered pair, and that looks like it's 2, 3. Then f of 3, we actually have addressed already, that would be 0. So when x is 3, what is y? So we get that. All right, next graph, again start with domain and range. So it looks like with the arrows it's going to keep going, so there's nothing restricting the domain. Range is a little different story in that I can see that my smallest y value is at 2, and then it just keeps going up from there. So I want to indicate that its smallest y value is 2 and it goes up to infinity. X-intercept doesn't actually cross the x-axis, so there'd be none in this case. The y-intercept crosses at 0, 3. We just said that there was no x-intercept, so there are no zeros. There's none. It was f of -3 and f of -6. Okay, so f of -3 says come over here to 3, and what's that ordered pair there? So it looks like it's 2. And f of -6 says go up to that point, and it looks like the y value of that is 3. Alright, down below, again, start with domain. You've got arrows that are going diagonally, so there's no restrictions on the x-axis. Y values, kind of the same deal. There's no restrictions anywhere up or down on that. Okay, x-intercept, I can see that it crosses the x-axis at -2 and at +2. So -2, 0 and 2, 0. Y-intercept, it crosses the y-axis at 4. So 0, 4. The zeros in this case, what number does it cross the x-axis at? And that's -2 and 2. And then we want f of -1, so come over there. Looks like it's got a y value of 6. And then I want f of 0. F of 0, it goes up there, and I kind of have it covered up there, but it crosses at 4. So that's that value. And last but not least, okay, so take a look at this picture. Any restrictions on the x? Technically this line is going to keep going down. Oops, switch colors there. It'll keep going down on us. So there's no real restriction as far as left to right goes. As far as up to down goes, I can see that there is a restriction at, it's like 5, but it's going to keep going down from there. So it's going to go from negative infinity up till 5, and then the asymptote says it's not included, so we want to put parentheses on that. X-intercept looks like it's crossing right at negative 6. So negative 6, 0. Y-intercept, sort of a little bit of an estimate there. I can see that somewhat a little bit above 4 and before 5, so I'm going to go 4.25. Again, that's sort of an estimate, so don't feel too bad if you don't quite match me on that. Zeros, again, is what number did it cross the x-axis at, and that was at negative 6. F of negative 2, so I'm going to come over here, and it looks like it's crossing that at 4. And F of negative 5 right there, and it looks like it's going to cross it at 2. So negative 5, 2 would be the ordered pair there.